Hello everybody, I'm Nicolas Vanermen from INBO Research Institute for Nature and Forest, and I want to tell you something on seabird displacement research at offshore wind farms. So seabird displacement should be regarded as a result of disturbance which can be defined as any behavioral response leading to a change in temporal or spatial use of an area, in this case a wind farm, manifested as avoidance of and as displacement from that area. The past decade, offshore wind farm-related displacement research has focused on assessing this effect by looking for changes in abundance and distribution. For example, here you have the result of a Danish research program on long-tailed ducks at the Nisset offshore wind farm, where researchers compared pre-construction densities to post-construction densities, showing highly negative changes, significant changes centered around the wind farm. This is a before-after gradient approach. In Belgium, we adopted the classical Becky approach, which you see on the right, and the bird on the left, common guillemot. Common guillemot showed equal numbers when comparing before and after construction in the control area, but a significant drop in numbers in the impact area, both being examples of good empirical evidence of seabird displacement going on. Now, last autumn, we have been reviewing seabird displacement research at 16 European offshore wind farms, including 21 species groups, which revealed consistent responses for several species, such as attraction of great cormorant and great blackback gull, and avoidance by divers, northern gannets, common guillemots, and razorbills. Not surprisingly, we've also found inconsistent results for other species, mainly gulls. Not surprising, since seabirds in general are very mobile species, and gulls in particular tend to aggregate in huge numbers, leaving other areas of sea completely void of birds. So, when birds are chopped in the middle by moving rotor blades, people tend to be very sensitive about it. When it comes to displacement, people are more, oh, so what, they move elsewhere. Indeed, this is exactly what's happening. The birds move elsewhere, they have to move elsewhere. But this so what question should be extended, especially considering the huge scale at which offshore wind farms will be built in the near future. So what does this mean what does moving elsewhere mean for an individual bird's energy expenditure, its foraging efficiency, reproductive success, or chances of survival? When birds need to go look for other areas to forage, they need to spend time and energy doing so. When they arrive in new habitat, these might already be occupied by other birds, implying increased competition, implying, again, decreased food intake rates. When birds have to fly further from the colony, this might affect chick provisioning rates and the chances of survival of the chicks. So when adding all these little local and individual facts up, one can ask the question, so what does this all mean for bird population levels? And how do we translate these little effects into a cumulative impact? So in conclusion, there is slow but steady increase in knowledge on displacement effects, yet there's still little insight in ecological drivers affecting the observed spatial and temporal variation in displacement. But more importantly, for a reliable assessment of seabird displacement impact, this is currently inhibited by a very poor understanding of some crucial seabird ecology aspects. Not in the least the density dependency, relative habitat quality, population carrying capacities, the relation between body conditions and chances of survival, and so on. So this is the major challenge for future displacement research, is translating effect into impact. So I thank you all for listening.